Okay, for this application, what we're going to do is answer the question that this stick person has, and that is, if I know the temperature in degrees Fahrenheit, what is that equivalently in degrees Celsius? But before we start coding, what we're going to do is we're going to design the algorithm, and then we can use our design and implement it in processing. So, a good place to start is to think about any program in terms of its input, what it does to process the input, and its output. So, in general, I have 3 steps. Input information from the user, process it, and then create some output. Okay, for this particular application, then we can figure that out and make some replacements that specify exactly what's going to happen. So our input is going to input the degrees in Fahrenheit. In our process step, what we're going to do is calculate it by executing our formula here, 5/9 times F minus 32, and that gives us our degrees Celsius. And then finally we can output our degrees Celsius at the end. Okay? So very simple algorithm in this case, just 3 steps. Input the degrees Fahrenheit from the user, do a calculation of degrees Celsius by this formula, and then output that result in a dialog box at the end. And that's it. So let's see how we implement that. Now we can go ahead and start coding our solution here to the problem. We can move on to the implement step. We'll go ahead and start with a good practice. That is, we'll do our comments. And we'll put what the sketch does, who wrote it, and today's date. Alright, another thing that we're going to do is, instead of jumping right into the code, we're going to actually use our algorithm and put in comments that point out the different pieces of that algorithm first. Okay, so we had an input, process, output algorithm. So I'll start with my input. I'm going to input degrees Fahrenheit first, and then after that we'll calculate our degrees Celsius. Next, output the result, and finally we'll quit the sketch. And that wasn't technically in the algorithm, but it makes sense to do it. Okay, so we have all these little pieces, and what we'll do is we'll code a little bit at a time. We'll try to do one thing, make sure it works, and then move on to the next thing. That way we're always confident that what we have, even though incomplete, at least runs. So let's start with our easiest part. How do we quit the sketch? Well, we quit a processing sketch by using the exit method call. And when that call is reached, then everything shuts down. And the reason we want to do this is because normally processing produces a display window, and in this particular instance we're just going to do dialog box input and output, and we don't really care about the display window, so this will make it go away once the user has seen the output. And if we run the program, we should see an application that starts and stops, which is exactly what we want. Okay, now let's go ahead and start to work on our steps. We'll do our inputting first. We're going to use what's called a JOptionPane object to do our input. And this JOptionPane object has various methods we can call from it. One of them is to show an input dialog, and the parameter that we pass is the prompt that will be displayed. By the way, all these things like methods and parameters and return values, all of those things will be talked more about in Chapter 3 when we talk about using objects. So if it's not clear to you now, just be patient and it will be. Okay, in order to use the JOptionPane object though, we also needed to have a little bit of a magic word up here, and that is an import statement. And the import statement is just a way of pointing processing to a library of code that's already been written, and in particular it's code that has JOptionPanes and knows how to show dialog boxes and things like that. Okay, now JOptionPane, show input dialog, will give me a string back. I don't want a string, I want a float, a number that I can use math on. So I need to convert S, which is a string that the user entered, into a float. And I'll do that with another object and method call. From the float object, I'll call the parse float method, and I'll send in the string S. So what that does is it takes the string, and assuming that the string is in the format of a number, interprets it as a floating point number and stores the result in F. Okay? Now let's just see if this runs. We won't be able to tell if it works or not, but at least I have a dialog box. I can type in a number, and then the sketch quits, which is what it's supposed to do. So I'll go ahead and save everything at this point so that I don't lose any work and move on. Next thing I'm going to do is calculate the degrees Celsius, and we'll use our mathematical operators to make that happen. And notice that I'm using parentheses to override the normal precedence level, and also to illustrate or to make sure that everything is plain to a reader of the code. A couple things here. The parentheses there, make sure that this 5/9 division happens first. Then the next set of parentheses is evaluated, F minus 32. And finally, those two items are multiplied together to give me my degrees Celsius. Before we move on, it's important to know that I did 0.0 on both of those literals, so that this would be floating point division and not integer division. If it was integer division, 5 divided by 9 would be 0. 0 times anything over here would be 0. So if I forgot to do that, every answer I got back would be 0 degrees Celsius. So that would be a clue that I did that incorrectly. Alright, let's try it again. Still runs and quits because I haven't done any displaying yet, but we can. So, output the result. I'm going to use JOptionPane again, and this time a show message dialog box. And what we'll send in, first one is a magic number that we don't really have to worry about, just a parameter that has to be there. And the second parameter will be what we're going to display. We'll use some string concatenation here to put together an output there we go, plus C, that illustrates or displays our result. Okay, now we should be able to run this and actually run it from beginning to end. So if we take in 74 degrees Fahrenheit, that is 23 1/3 roughly degrees Celsius. It'd be a good idea to test with some values where I'm confident of their results. So for instance, I know that water freezes at 32 in Fahrenheit, should be 0 in Celsius, that turns out. And if I run it for 212 degrees Fahrenheit, which is where water boils, I get 100 and a little rounding error in Celsius. And so good. I'm confident now that this works. One last thing before I stop the recording, and that is what happens if we enter something that isn't a number. So if I enter only be a string here instead of a number, so this can't be interpreted as a float in a straightforward way, I get what's called an exception. You can see a number format exception, and it highlights where the error was. So that's what's called a runtime error, not a syntax error, and helpfully it tells me where it occurred. Later, in another course, we'll learn how to handle exceptions and make it deal more gracefully with those. One last thing, notice that the application is still technically running because it errored out before the output could be displayed, so I need to click the stop button to make it go away. And there we have it, a sketch that converts Fahrenheit to Celsius.